So welcome back to all. So here some application as I have explained some system of particles and due to some shapes of the bodies, electric field how to find out and neutral points and electric field due to different shaped bodies, formulas, everything I have given. So some more applications by this class I learned. So any other doubts, other models of problems you have, you can ask me. You can send to my WhatsApp number. I will use my WhatsApp number so I can try to explain. Right here, see. So this is the given question. So rod is there. Rod of positive charge Q and length 2L. The charge is uniformly distributed. And at the point B in the distance R from the center of this rod, there is R distance P is given. Sometimes they will go here to here R distance. So integrations are to 2L plus R to R plus L. So however you can take, no problem. Point P always unit test charge is positive, so D is charged body. So the field, this is two consider, this is the one body consider, one rod, second rod. D to the first rod on axial position, this is E1 and this is E2. The angle between E1 and E2 is given 60 degrees in the question. So therefore, E1 is an axial line. So E1 is an electric field is an axial line, that equal to K into 1 by R minus 1 by R minus L. So here R means what? R plus L. R means this is the formula. R K cube by L will be their answer. Here R means distance from the rod to the point. Here D is given, therefore D will consider. So that equal to K lambda into how much will come here? R into means D into D plus L. And here D plus L LCM after LCM minus D. So DD get cancelled. That equal to E is equal to K lambda L by D into D plus L. So here lambda plus Q by L I can substitute for this rod. Linear charge density Q into K into QL by L into D plus L. So LL get cancelled. Therefore, E is equal to E1 is equal to E2. Both are on axial points and same distance. So E1 is equal to E2. Here if you see E2 is not in the direction because it is the negative charge, right? Therefore, E2 in the direction. This is the E2. So the angle between E1 and E2 is 120. Remember this. Therefore, E1, the magnitude of E1 is equal to magnitude of E2 and angle between them E1 and E2 is equal to 120. In that case, answer E net is equal to E only will come. Answer root over E1 square plus E2 square minus 2 into E1 E2 cos 120 means minus 1 by 2 will substitute plus minus 1 by 2. So that cancel na 2 get cancel, you will get E1 square plus E1 square minus E1 square, E1 square get cancel means E1 or E2, that is net electric field is E only according to vector addition. So E is equal to here K Q by means K means here 1 by 4 pi epsilon that equal to Q by 4 pi epsilon naught into 1 by D into D plus L. This is the answer. So here this is only application and finding the direction of electric field, angle between them and adding those. So similarly, so in this model, so here see, so calculate the electric field at the point P is x comma y. Here there is a point given, x comma y point is given. So here this is the point P, which is x comma y, and these are infinite rods. So we already studied the electric field due to infinite rod. E is equal to 2k lambda by R or D or R A something distance. So K means 1 by 4 pi epsilon naught. How this formula K means? So infinite rod you consider infinite rod or wire of charge. In the distance D there is a 1 point. So here DQ element will consider. So DQ element is making angle theta. This theta is varying to alpha angle and beta angle. In Biot-Savart's law also we will use the same thing. So here you will get E is equal to E at this point dE cos theta after integrating K Q by D into sin alpha plus sin beta. This is the formula we will get find. K Q by D. So here lambda is equal to Q by the length, given length, that is 2L or L into D. D is the distance from the rod to the point P. So if it is infinite rod, so now this point is the angle alpha and beta will become 90 degrees. Alpha and beta becomes 90. Therefore, here it will be 2. That is equal to E is equal to 2Q by L is lambda. I will take 2K lambda by D. This is the answer. So by means this formula, by general formula of this one, we can use and we can find out. This I will explain in Biot-Savart's law in electromagnetism. By using this, so these are the infinite rod arranged in the flush form. So now, so consider this is the one rod and this is the second rod. From the second rod distance is x and from the first rod is distance is y. Therefore, E1 is equal to here. The E1 is equal to in this direction. This is E1 along y direction. E2, D2 the second rod is in the direction. Therefore, E1 is equal to 2K lambda by x along I cap. So, E2 is equal to 2K lambda by along y axis. Therefore, E is equal to net electric field E2, these two at point P is in the direction. Otherwise, it is in the direction of root over x square plus y square. However, you can take, not a problem. But here charge cannot be defined for these points in this distance. That's why we'll go with this formula only. 2K lambda by x and 2K lambda by y will take for individual rods. And total electric field E is equal to sum of those two, vector sum of those two, E1 and E2. That is equal to root over 2K lambda by x whole square plus 2K lambda by whole square. So that is equal to, so here you can take 2K lambda common, 2K lambda take common, that equal root over 1 by x square plus 1 by y square is the answer. So that equal 2K lambda means Q by L into L is the length of the rod, otherwise lambda only keep, no problem. So for example, infinite rod na, so that's why lambda only keep like that. 2 pi epsilon naught into root over 1 by x square plus 1 by y. So in this case, you can find out it. For example, this is the E net resultant electric field of E1 and E2 or by these two rods at the point P. The resultant making angle with E2. So E2, angle with E2. Then tan theta is equal to E1 by E2. Y component E1 by E2, that equal to 2K lambda by x into y by 2K lambda E2. So 2K lambda get, therefore theta is equal to tan inverse of y by x. So this is finding the direction of resultant electric field with x axis. If theta is given with y axis means that is theta is equal tan inverse x by y will come. Equal to opposite field by adjacent field for theta. So this is the direction of field. So this is calculation of field by using the formula infinite rod formula. Moving to next question. In regular hexagon, we see here, each corner, regular hexagon means here, so sides are equal. The regular hexagon means the sides are equal. And from the center, all the corners are in the distance R, is given R. And in the 5 corners, there is a 5 charges are there. Q1, Q2, Q3, Q4, Q5. 5 charges are placed at the 5 corners. The field at the center is asking. So here 2 ways you can do to find out the field. So these are the same charges. So the field D to Q5 and field D to Q2 are equal in magnitude and opposite direction cancels. the field due to Q4 and field due to Q1 equal and opposite cancels. Therefore, there is only field due to Q3 is there. Okay. So therefore, K is equal to here field at the center E is equal to only by Q3 or only by Q5, any one charge. Otherwise, we know if there is a one Q6, another 6 charge I am keeping here, the net electric field is 0. Therefore, the net electric field which is equal to the electric field producing by the 6th charge in this direction, or the electric field by 6th charge and 3rd charge are equal, remaining charges are cancel each other because identical, all are identical. If any one is, this is 2Q, Q2 is equal to 2Q is given, then resultant electric field between Q5 and Q is equal in the direction. If it is given 3Q, then resultant direction will be in the direction. The resultant electric field, if they are not identical, different charges means resultant electric field is exist here, and this means you have to find out the resultant of all the fields by taking the angle between them. So now here in this case, similar charges at 5 corners. So the similar charge at the 6th corner we are placing the electric field is 0 at the center. So that is means the electric field due to 6th charge is making all the electric fields cancel each other. That means as shown in the figure C, opposite charges equal electric field produces in opposite direction. So cancel, only Q3 is remaining, that is equal to KQ by R square. That's enough, very simple. That equal to Q by 4 pi epsilon naught into R square. R is the distance. If in the place of R, he will not give this R. So he will give the L is the length of side of hexagonal. Then this also will become L. So now L square will come. Otherwise, some different charges are given means you have to find out all the things. So this is about regular hexagon. In case of the same thing, they will ask these charges, they will give the different nature, means one is positive, one is negative. For example, see here 2Q, 3Q have taken the resultant field of this one in the direction, in this one in the direction, over this angle will find out, these two get cancelled, this Q and this Q is same in, these two get cancelled. So now the electric field will, the angle between this is 120 will come in this numbers, it will be 120 will come. So now here resultant of this field you have to find out here, and this field root over 1 square plus 2 square plus 2, field 1 and field 2, field 5 cos theta. So that will apply. Otherwise, here in the place of 2Q and 3Q, our alternate charges are negative, they will. So same regular hexagon, 6 charges are placed. Charge is equal, but alternate charges are negative. So this is another question. Here hexagon you take, or you can take another square or rectangle or equilateral triangle. This is plus and here. So at the center field is asking to find out. So these are same charges, right? So due to this Q repulsive in the direction and attractive, both are acting same direction and same. So this is 2 K lambda by R square. So here also the field is acting in the direction. So that equal to 2 K lambda by R square. Here also the field is acting like this direction, that is equal to 2 K lambda by R square. So now resolve this field into X component and Y component. Similarly, this also X component and Y component. So this is already in a minus I direction. So now here you will get, means find out this angle and this angle. I think 60-60 will come. So we will find out. Otherwise, resultant of these two fields in the direction and subtracting this one and this one, you will get the resultant. So like that, the model of the problems will. So coming into next model. So this is something important in this model. Major problems will come. First, I will complete this one check once. So question number 5. So there is a ring of radius R. So it is negative charge. The charge uniformly distributed negative charge minus Q. So minus Q, the charge distributed over the overall the uniformly charge distributed on. So here same. Here how much charge at the center I want to place? Q is question mark. How much charge I want to place at the center? To get electric field 0 in the distance R from the center at the point P here, the field should be 0. E is equal to 0. So how much Q at the center I need to place? The charge of Q is how much? So here Q is equal to question mark I need to find. So I know field due to the ring at this point, the field due to the ring, and here minor charge, it will be attractive at this point. So in the direction, this is the field due to ring. And so you should get the 0 here at this point, then there will be equal and opposite field should act in this direction, that is by EQ. Means due to this charge. These two are equal in magnitude and opposite in direction. Therefore, we know already ER is equal to KQ into X means here R by R square plus X square whole power 3 by 2. Here X is equal to, and EQ is equal to, we know EQ is equal to then EQ is equal to, I know, K into Q by R square. Direct line joining. These two are equal. That equal to KQ into R by this value 2R square whole power 3 by 2. So that equal to K into Q by R square. So now here K get cancelled. Here R by, so this is 2 cube, 2 root 2 into R cube is equal to, here Q also there, by R square. So this R square and R get cancelled. That implies the required answer Q is equal to Q by 4. So Q already I decided, that is positive charge, repulsive electric field. So in the direction electric field, so repulsive electric field, Q is equal to positive Q by root. So this is one model of the question. So now coming into this model, this is somewhat important. So like this model for different model of questions will come on this model. So clearly observe here, 4 identical charges Q are placed at a corner of the square. So consider a square. So here 4 charges are there at the corner Q, Q, Q and Q. And the charges name as 1, 2, 3, 4. So in some cases they will give, so here these two are positive, these two are negative. 1 and 2 positive and 3 and 4 are negative. They will be. Otherwise 2, 3 is positive, 1, 4 is negative. However, they can give. But here all are positive given for understanding. And in some problem, the diagonal is root 2L they will give. The square of diagonal 2L, one model of the problem. So all these things can be calculated by this one. So here in the perpendicular distance, the perpendicular distance is given A by root 2. And here square of side A is given. So then diagonal will become root 2a. This diagonal will become root 2a. And this half of the diagonal is a by root 2. Therefore, from this end, this distance is a will come. For all the distances, it will be a. For all these distance is a. So now take diagonal charges. So this is the line of 2, 4, 2 and 4 charges. Diagonal charges we consider. So it is easy, whatever the charges are given, that is why I am taking diagonal charges. From this in the perpendicular direction, a by root 2, for diagonal it is perpendicular, that is why diagonal I am taking. So in the perpendicular direction, there is a by root 2 distance, here also a by root 2 distance. So there is a point B here. So this distance is a, this distance also a. So now field, this is all are positive charges, therefore the field will be like this, and the field due to this one is like this. The resultant of these two will be like this. So it is a line acting, for example, this is OP, it is acting along OP direction. So now here if you take theta, it is automatically cos theta 45 will come, because these sides are equal, a by root 2, a by root 2. So these thetas also equal, compulsory right angle triangle 45 will come. So this also theta. Okay. Now this one resolving into in this direction and this direction, and this one also resolving into in this direction and this direction. So the resultant field is equal to here by these 2 and 4, the resultant of electric field 2 and 4 is equal to 2E cos theta. So along OP direction. Similarly, if you take 3, 4 charges, you take 3, 4 charges similarly. So you will get like this concentration means diagram. So now you take here 3, 4, 1, 3. For this 3, 1 line also perpendicularly there is a point P, a by root 2. That is the reason I am taking diagonals. Again I explain, this is a by root 2 distance, because side A means root 2a and a by root 2 this is. So this distance and this distance are equal. So this is 3 and 1 charges. So here also it is like field acting along OP direction only. So this is O point. So therefore E13 also is acting some magnitude of electric field and or force or field you can find out. So that will be 2E cos theta along OP direction. Both are same direction, therefore resultant will be added. So E bar is equal to, we'll add 4E cos theta. Here theta already I have given 45 is coming, because from the given data. If not given, na cos theta value, you have to substitute, that's enough. 4 into E is equal to here, from this, the distance from this charge to here positive charge is A, that is equal to KQ by A square, KQ by A square into cos theta equal to 1 by root. So that equal to KQ means 1 by 4 pi epsilon, that equal to Q by root 2 pi epsilon naught into A square. So this is the answer given. Suppose here 1 and 2 are positives and 3 and 4 are negatives. So that is the condition. So now take this example. This is the square. So here square means all sides equal. Don't look into, don't know how to draw the square like that. So perpendicular distance A by root 2. Now this is 1, 3, 4. These charges are positive, Q and Q. So and here not this one. So perpendicular 90. Here the field d to 2. The field d to 2 is repulsive because positive charge it is in the direction. D to 4 is in the direction attractive. Field d to 4 towards the 4 attract. The resultant of 2 and E4, 2 and 4 will be along the direction, means parallel to 2, 4. So this is E24 along the direction of this one. So this is 3 means negative attraction and 1 is repulsion. This is E1 and here along this direction E3. Therefore, along the diagonal, in the diagonal, in this, like this. So there will be a resultant field parallel to this line. So the diagonals intersecting point, the diagonals at the intersecting points make 90. Therefore, E1 to E24 and E13 magnitude again, E13 A square. So E1 K cube by A square and E2 also K cube by A square. E3 also K cube by A square. E4 also K cube by A square. The resultant of these two will be here also 90, that equal root 2E. So now this is substitute now. Therefore, E net is equal to root over E24 whole square plus E13 whole square. E24 is the resultant of E2 and E4. So that equal, this is root 2 into E. E is equal to K cube by A square, all the E's, right? Whole square plus, this is also root 2 into E whole square. So that equal root, overall root. So now that is equal to E is equal to, so root 2 means 2E square plus 2E square, total 4E square, that equal to 2E. So that equal to 2 into 2 by 4 pi epsilon naught into K means here for K cube means 1 by 4 pi epsilon naught Q by A square. So 2 get cancelled, therefore Q by 2 pi epsilon naught into A square. So the charges alternate they can give. This is QQ and minus Q minus Q. So then what is the charge you will find out. So this is the model how to find out the direction of electric field and calculation is the answer. So if we understand these models, so this is enough. And next I will explain dipole in the next class. No, motion of the charge in the electric field. Then after I will explain the dipole. Thank you everyone. Thank you all.